Hello everybody, welcome to the Overwhelmed Spring Developer's Guide to AI. Today what we're going to try to do is kind of show you how we can blend various types of Spring together with Spring AI and see how they work. We're going to show how we can blend them together, how they can work in cooperation. The foundation of this talk came in as a part of AJUG. I have an opportunity to talk with many of y'all, and what I found is that a lot of us have already begun to using AI as a part of our development process to help us kind of generate some code, help us kind of start our tests, help produce documentation, even to say, my brain is hurting so bad, can you please look at this code and tell me what it's doing? So it has these wonderful opportunities for us to be able to kind of increase our productivity. But what we also see is that we are starting to use AI in many parts of our life. And there's even times that we are using services that have AI in the background and we don't even know. So in this case, we are probably going to be working in the AI environment by creating apps that interface off of services that we write that will utilize AI models. Now, with that being said, who am I? Well, my name is Glenn. I am one of the organizers for Devnexus. I know it's hard to believe, but it's true. I'm also on the board of directors Atlanta Java Users Group. And when I am not doing that, I'm also on the Spring team, as well as Java Champion. But I want to just do a quick shout out. I want to, as I mentioned this morning, when you're setting up a conference like this, what we do is we create the scaffolding. Y'all are the people that make it great. You're the ones that actually build up the structure. You are the foundation to what this is. And I want to thank y'all for coming to Devnexus. So thank you. Now, I can't see, but do I have any volunteers that volunteer for Devnexus here? I see. There we go. A special shout out to our volunteers. Yes. Thank y'all for being here. Thank you. Y'all made this fantastic. So give them a round of applause, folks. So I'm going to say this is a very small microservice architecture, and it is happy. Look how happily they're working away with each other. And you're like, our microservices aren't quite that happy. Okay, all right. So we're going to pretend this is in a mystical realm where they're happy. But we have a project manager who says, I want to introduce a service. This service might be a chatbot. It might be something that can look at events and identify specific events using an AI model to be able to maybe take certain events that have a certain type of value to them, so that we can begin to start a campaign to email some of our customers on very specialized discounts or things that they may want to buy. So with that, they introduced AI service. And all of our services are shocked. Oh my gosh, what have you done? No, they're actually going to be okay with it because why? They're going to still communicate with this service, right? As if it's any other service, the same protocols, whether it's HTTP, whether it's maybe we're using something like Kafka or Pulsar or even Rabbit to be able to communicate. So they're fine. Now when it comes to us developers, okay. Now we're introducing yet another technology. And this technology is going to put a little bit more cognitive load on us. And when we talk about cognitive load, what do we really mean? That is the amount of memory it takes for our brain to process and be able to do our work and our daily life. By adding this, we're putting more cognitive load on us because not only do we have to know, how we designed our apps, what technology was in our apps, how our apps are interfacing with other services, how these services interface with us, the platform it's on there that it deploys to. And now we're going to be adding AI models on top of that. So what do AI models do? Here's a very small selection of some of the more common things where it's more like, okay, we can do chat completion, embedding, text to image, speech to text, text to speech, and so much more. And you're like, okay, well, these are great features, but I've got to figure out how to make these things work, right? But then we have the multiplier here. How many different services or models are out there? Everything from Anthropic, OpenAI, Microsoft, Google, Llama, DeepThink, Mistral. We have all these out there, right? So now what we're talking about is to get these services, we'll have to know which of the models support what service. And then on top of that, we have to have a unique view of how each of their APIs work. So we're like, okay, that's a lot more stuff to think about. What can help us out? Well, believe it or not, Java is one of those things. Java is 30 years old. Does that mean it's just out of date? Absolutely not. We have a release cadence for Java once every 6 months. And many of these add new features, improvements, and they actually are introducing a vector library in, I think, the next couple, 3 releases. So that's going to be able to say not only Java be able to just be using AI models, but also give you the tools to be able to create models. There's actually a Java project out on GitHub where they're actually doing that now. Instead of using Python, they're using Java. What other tools do we have at our disposal? Now, since I'm working with Spring, what do you think I'm going to say? Yeah, I know. Who said Quarkus? No, sorry. Okay, my humor's bad. Just nod and say, well, and keep it going. All right, with that being said, Spring. Spring has this basic foundation that says, look, Spring allows you to blend multiple technologies together in such a way that it feels natural. It basically gives us a consistent method of being able to utilize technology out there. A classic example is Spring Data. Spring Data says, look, you have a consistent way of querying and update a database regardless of the database type, whether it's a graph DB, a relational DB, you take your pick, right? Now, with that being said, it also says, look, I not only can do that, we also support all those vendors for those database types. And if you need to, we also provide you specialized features that allow you to utilize the strength of that database type, or it can actually just easily stand aside and let you use the direct features that are offered by that database for a particular database vendor. It's up to you on how you want to use it. And Spring says, okay, we can, that's our foundation bit. So is there something that we can use that allows us to do that? And the answer is, of course, Spring AI. Spring AI says, look, at its core, it addresses the fundamental challenge of AI integration, connecting your enterprise data and APIs with AI models. What does that mean? No matter what API model you have a consistent method of being able to utilize those services each one offers. So whether you're using a Llama or DeepSeek or OpenAI, it doesn't matter. The methods that you use on one will be able to be used on all, okay? The only exception is like what we're going to show in a few minutes. I'm going to be doing text-to-speech, and speech-to-text. And some models support it, some don't. But Spring AI gives you a consistent model for being able to utilize that, and we're going to show that. So that's what we're showing here. I don't have to learn each of the various APIs of all the various models out there. I just learned Spring AI, and I can use all these services and much, much more. But then Spring AI takes the next step. It says, look, there are things that I need to do once I need to interface with that model and also get data back from that model. And do I have to write all that code? Do I have to do all this work? The answer is Spring helps you out here too. It gives you structured output, so I'm dealing with POJOs. I don't have to deal with the API direct results. I know what I'm getting back. It's going to be this type of POJO. I have this certain level of interface I can interact with. It gives me a consistent method of being able to connect to vector DBs, and it supports many vendor vector DBs. It also provides us a simple way to add tooling, and what we mean by tooling is this. Let's say that we need to be able to have a up-to-minute price available to the model as it is actually working through and creating a response. The model does not know the current price. It only knows what was maybe available a week ago, month ago, or whenever it was last generated. In this case, we can actually apply a tool that it can call to get the latest price. It could be temperature. It could be even calculations. In this case, we're going to show the calculation part. It also simplifies the ability to get observations and metrics from our how we're utilizing the model so that we can follow the trends, and not only follow the trends, but maybe identify how we can optimize or even prevent a major error in what's coming up. It also offers something called evaluators or evaluation. And an evaluation basically is this. When we are writing our applications and we introduce AI, in many ways we're taking a deterministic system and making it non-deterministic, meaning sometimes it's not going to return the same value. And that sometimes comes in the form of hallucinations. How can we reduce hallucinations? And we can do that through testing. Spring offers something called evaluators, which allows us to be able to add these to the test so that we can do that type of testing to make sure or to reduce or remove the possibility of hallucination. And that an example of that would be LLM as a judge, where I actually take another type of model and actually test the results of the model that we're actually implemented within our app. Why would I do that? And the reason I would do that is the bias that we could get from our base model. An example is today we're going to be using OpenAI. I would not use an OpenAI to test the results of an OpenAI because itself would look at it and go, man, that is a fantastic answer. Right on. Yes, that's right. Because it's biased. That's what it would say. What you want is another AI to come in and model to say, maybe I wouldn't say it that way. No, that's not right. But moreover, you would want to have it tell you why it said no and give you an explanation of why it said no. The other thing that we have is advisors. So as we are allowing data to go into or prompts into our model and results out of our model, we want to be able to maybe filter the results that are going into the model. Maybe you want to modify the prompts that are going into the model. And even the data coming out as results out of our model, we may want to do some filtering or modification. Advisors allow us to do that. A classic case of an advisor in this case is something called a constitution advisor. A constitution advisor says the following: does this prompt that's going into my model meet our ethical, legal, or financial rules of our company before we let it in, right? Trying to bypass bad actors or even prevent what? Some hallucinations. And lastly is MCP. And MCP is Model Context Protocol. This is something that was released by Anthropic, I believe, back in November. And it basically creates a context for communication between the model and your data, resources, or the services, simplifying that interplay between the two. Spring AI offers a simplification of that. If you're trying to figure out what that icon is at the bottom, you have to know that you have to be at least this old to know. It's from Tron. It's the MCP, which was the bad guy called the Master Control Program. Yes, I snuck an old 80s movie sci-fi in here. I apologize. All right, our business case. So we're going to go back to Spring Pet Clinic. And with our Spring Pet Clinic, we're going to basically add let's put it this way. We're going to pretend that Spring Pet Clinic has been providing nutritious, tasty dog food, cat food, ferret food, fish food for our pets. And people are saying our pets really love this stuff. So what we want to be able to do is that people are buying it, but what we want to do is make it where people don't have to come in to pick up the food. Well, what we may want to do is have a drive-through and have people come through the drive-through to pick up this food. Now, to do that, what we want to do is have AI to be able to receive the person's order. Then we want to be able to verify the items that they order are actually on the menu. Then thirdly, what we want to do is be able to repeat back to them the order and say, is this what you ordered? And then lastly, send that order on to fulfillment. Can we do that? So the first part we're going to do is we're going to use speech to text, and that's going to use Spring AI. The next part, we have a couple of options when we do validation, and we're going to show this. We'll have the ability, when I send my prompt through, to be able to give it the menu, and that's called packing, where I can actually provide the menu as a part of my prompt so that it says, please verify the person's order, here's the order, against this menu. Now, sometimes when we are dealing with with prompts, and the amount of data that comes back is too large for the prompt. Now, I know we have like Google out there that I forgot how big their prompt is, and they pretty much say pack away, throw all the data at it, our prompt can handle it. But some of the other models say, no, we only have this restriction of how much it can be. The workaround is RAG, and basically what RAG does is it says it basically takes and takes your prompt and creates a series of vectors called embeddings. It then takes and sends that those embeddings, and it does a similarity search against a vector database. And then upon that, the vector database will turn back the documents that apply to that particular search, giving you a smaller prompt. Now, to do that part, what we're going to do is use Spring AI to actually go in and utilize the vector database to do that similarity search. But the database has to be loaded first. So Spring AI offers a series of wonderful tools to simplify that. For example, if I have my menu and all my documents in a PDF, it takes and creates a wrapper around what's called the Apache Tika reader, which says, in the Tika reader basically says, I can read like 100 different formats and provide you the content of that file, as well as the metadata. And Spring AI has created a wrapper for that, so that simplifies how I read the stuff in, but it also in turn simplifies that it will actually go out and hit the AI for us via what we call the vector store. We'll show this, and create the embeddings for that document and store that in the vector database. And that's great, but that still means I have to do a lot of boilerplate code if I want to read, let's say, not one file like in my demo here, but maybe thousands of files. So in that case, if I'm having to read thousands of files that may be updated every so often, how can I do that without having to write all this boilerplate code? What if I blend Spring AI with something like Spring Batch? Have them work together to create the solution. What does Spring Batch bring for me? Spring Batch basically allows me to get features like restartability. Let's say I have 1,000 files I'm reading, and halfway through the database goes down. Okay, we find out it was a hiccup in the database. We start it back up. When I start back the batch job, I want to have it pick up where it left off. Spring Batch allows us to configure our way so that we can actually have that feature. It also allows me to be able to plug in, and again, by removing this boilerplate code, I can focus on writing processing code that may filter or modify the data I'm storing into the vector DB. So we're going to blend those two together today. The next thing we want to do is we want to do text-to-speech, where we respond back and give the user a confirmation. Then I want to guarantee that once I've done this, I want to send the order for fulfillment. But I want to guarantee it gets there. So I may use a messaging framework like a Rabbit, a Kafka, or a Pulsar, and send that data there to the fulfillment system, but I don't have to write a lot of code to do that. So we're going to use Spring Cloud Stream to do that for us, and we're going to show you how to do that today. So we're going to show how we can use Spring AI in combination and in cooperation with other Spring tools. Now, by the way, it's all built on Spring Boot. So let's get started. And what we're going to do is we're going to go to IntelliJ. And I've already started a project, but when I go to start.spring.io, there we go, and I say I want to use OpenAI, and not only do I want to use OpenAI, I want the Spring AI using OpenAI. And when I do that, it's going to provide me this starter, the Spring AI OpenAI Spring Boot starter. Now, once I do that, it's going to give me all these wonderful auto configurations so I can take advantage of the features that are offered by Spring AI. And the only thing I need to set, I know this will be hard to read and I apologize. And let's go here, is add the following environment variable, which is this. It's just Spring AI OpenAI API key. That's it. Now you'll see there's other configurations, and that's just the basic URL that I'm going to use in order to connect to a vector database. And today we'll be using PG Vector or Postgres Vector. All right, let's cancel that. What's my driver here? What's going to drive the application? Well, I'm going to use an application runner that's just a part of my main Spring Boot application. And in this case, the application runner is going to call the take order method. The take order method, if I just hit the enter key. So let's think about it this way. I drive my car over the sensor at the menu board, and it trips the sensor to say, okay, now I'm listening for your order. In that case, what I want to be able to do is that's going to be represented by hitting the enter key. Once I hit the enter key, I'm going to give it a verbal request for the order. And that is and then what it's going to do is give me a reply back. Now, a little later on, you'll see where I'll hit D and enter, and that's way I can just give it a default order instead of me keep repeating the order over and over again. All right, so let's take a look at take order. And that's actually just right here. So we have take order, and we see the first thing it does is it's going to call a service called speech handler. Speech handler, what it's going to do, it's going to record my order. And once I have my order recorded, it's going to then convert it to a text. All right, now the thing to think about here is that the speech handler is going to do 4 things. It's going to record my voice, then it's going to take my voice, the recorded voice, and change that over to a text, and then it also reverses it the other way. When I give it text, it will change and hit off like a model, convert that text to speech, and then play it back. And we're going to demonstrate that. The other service we have is our chat service, and this is where we do chat completion. And this is how we're going to send a prompt for it to give us a reply back. So if we look at the speech handler, let's do a bit here, and we see, let me go scroll up here, we have record order. Now, record order utilizes 2 major features. One, Spring AI. The other is, this is actually pretty cool, JavaFX has the ability to record and play back. The reason I chose JavaFX is, while there were other packages I kind of liked, the license for JavaFX was wide open, and it's what? Free, open source. So I decided to use that, and we can just take a peek and see when we look at the record order, you see where I'm actually recording the order. I specify the audio format, and then I save that off to a file system. So just kind of easy, quick, something I can store off really quick. Once I record it, I get the location of the path to where I recorded that my order. And then I'm going to use the auto-configured transcription model provided by Spring AI. I'm going to call it, and then I'm going to pass it what's called the audio transcription prompt, also from Spring AI. I hand it a resource, and that resource is what? The file I just recorded. Once I call that, I'm going to get an audio transcription response. And this is a pattern you're going to see a lot today. You get the response, you get the result, and now I get the output, which is a string. And when it's time for playback, and we've hit the chat service, got a response, we go call text to speech, and we're going to take a speech prompt, and then we take that speech prompt, we're going to use the auto-configured speech model, we're going to call it, and it's going to give us a speech response. And that response, yet again, get response, get output, but in this time it hands us back a byte array of the verbal response we get back from our model. And then, of course, we call play response, which takes the audio response, utilizes the media player provided by JavaFX, and plays that back. The chat service, you probably saw this in the previous, is it basically takes in a prompt. We used a chat client provided by Spring AI against the chat model that's auto-configured from Spring AI. And from that prompt, we pass in a prompt, a call, chat response, and you've guessed it. Get result, get output, but in this case, the output has actually multiple fields that we care about. In this case, we say get text. So we now see that we fulfilled record, the response, and of course, get the response and play it back. Let's see it in action. Okay? I'm going to hit the enter key. I want dog food, cat food, and a Lamborghini. It may be hard to say here, but I'm going to see if I can juice this up a little bit.
Thank you for your order. Just to confirm, you'd like dog food, cat food, and a Lamborghini. Is that correct? If there's anything else you'd like, or if I misunderstood, please let me know.
Very pleasant. And I forgot to show you the prompt I sent it. What's this? You're a drive-thru employee. This is part of the chat service. From the order given, extract the items from the following order and give them a friendly, curt acknowledgement confirming their order. Ask them if the order is correct. If you don't understand, please let them know. And then I append the order. And that's exactly what it did. But there was a problem. Was it a user problem? In a way, I ordered a Lamborghini from a pet store or pet clinic. Let's see if we can stop that by maybe helping our customer out. So in this case, we're going to go, that was phase 1. We have 3 phases of this demonstration. Okay. Now we're going to go to phase 2A. In phase 2A, we're going to add validation. We're going to say, yes, you have cat food. Yes, we have dog food, but we don't have a Lamborghini. And let's go ahead and play with that. Now, the first thing I want to be able to do is actually load my vector store with our menu. So how can I do that? So I do have a project here called batch. Let's see what I call it. I actually loaded the wrong project. See, look at that. Menu batch. There we go. No wonder I couldn't read it. There we go. Menu batch. So menu batch is a Spring Batch application that utilizes Spring AI. So what does this look like? Well, the first thing you'll see is I've got my menu. It's just saying, here's my menu, here's the location. And if you never played with Spring Batch, a quick primer is that a Spring Batch says, look, you have a job. Each job has a series of steps. The most common steps are, within a step, you do a read, a process, and a write. So I can have a job that can have many steps. Each step is a read, process, write. And the cool part, again, about Spring Batch is it says, look, you don't have to write all this code. I'll handle the transactions for you. You configure that. When you want to go in and have restartability, you configure that. When you want to have processing, write the bit of code. You add a processor. So we're going to take a look at how we did this. So remember, we have a read. I have my reader. I declare my reader bean. We'll take a look at it in a second. You'll see I have my writer bean. And then we have where we create our job. Like I said, we have a job. The job has one step, and this is what we call a single-step batch job because it has only one step. And in that step, we do a read and a write. We're not doing any processing today. We're just doing a reading and writing, and it's perfectly legal. I'm reading from the PDF file, and I'm writing that to a vector store. Now, where's the magic happen here? Let's go take a look at our Tika item reader. And remember, Tika, again, is an Apache project that can read multiple formats of files and be able to, from that, give us the content of that file as well as metadata. But Spring AI does a little wrap around it to simplify it. So what we're doing here with our Spring Batch is utilizing that service that Spring AI gives us, and we use what's called Tika Document Reader. We give it the resource, again, the file or our menu PDF. And then we have what's called a text splitter, which is given to us provided by Spring AI. And it says, I'm going to look at this look at this file, and based on how you want me to do this, I will split this file into what we call documents. Each document will represent a row into my vector store. And then what will happen is I will send that document to my writer. So would send it to the processor if we had one, but we don't have one. Then we have our vector store writer, which takes the vector store and then accepts each document that is provided. Now, the thing to remember is that with this accept, what it's going to do is going to take the document that it has, and it's going to get what's called the embedding, remember the vectors, and store that into the vector database so that we can actually search against it or do that similarity search. So let's go ahead and run that. Spring Batch ran, did all that work for us, it's done. So let's look at what that looks like from our database, and I'll make sure we see this, hit refresh. We have our tables. What does that look like? So let's take a look at what we got. In this case, there was only one document. I know this is kind of hard to see, but you can see, whoop, there we go. My gosh, be there, represent. Okay, guess not. So in this case, we can see that it has the dog food, cat food, ferret food, spider food, bird food, rabbit food, all sorts of food, right? And here are the embeddings. This is what we got back from OpenAI. All this was done by what? Spring AI. It did all this work for us by accessing and getting the vectors back from OpenAI and storing this. But Spring Batch simplified. I only had to write that code, and now I can expand that code, say, don't read that one. Read 500, read 1,000 records. And I can do that through, again, a little code, a little configuration instead of doing all that boilerplate. Now our vector store is loaded. let's go back to our, can I have your order application? We're going to go to the chat service. And from the chat service, we see there's a little hiccup here. One related problem. So what I need to be able to do is I need to be able to access that vector store. So let's go ahead and add that. So let's go to our pom.xml, right below where we had our OpenAI starter. And what we're going to do here is go ahead and add our PG vector. Again, we're going to get a boot starter saying I want to use Postgres Vector DB. I want to go ahead and have you auto-configure that stuff for me. So we're going to hit refresh. We'll go back to our chat service, and we're going to go ahead and do this. We'll have what we call vector store. Oh, went a little bit too far there. Sorry, chose the wrong one. Vector store. We'll pass in to our constructor, vector store. Then do this dot vector store equals vector store. So we now have our vector store. So how can we apply our RAG implementation here so that it can take our prompt and add in the menu? But before we do that, let's look how we may have modified the prompt. Remember the original prompt we had? Where we said, and give them the order if it's, make sure the order is correct. But I also say, also verify that items order are on the menu. I have some text after that that says, look, only mention the word menu if they order an item that's not on the menu, okay? So I give the modified response, but I still need to apply that, the menu to it. So I'm going to use an advisor. Remember we talked about what advisors do. Advisors, what? Modify or filter the data or prompt before going to the model and the data coming out. In this case, we're going to do it what's coming in before. So we're going to utilize Spring AI to help us out here. So what we're going to do is we're going to see that we have something called the Retrieval Augmentation Advisor. It does a builder. We specify the vector store, and then we say we want to use a similarity threshold of 0.5. You can have a point, the higher the number, the tighter the restriction will be, how tight it's going to actually do a response. I have it at 0.5, which is pretty low, but I want people to be able to say, I want puppy food, and it says, oh, you meant dog food, right? So we want to be able to catch that. So how do I take this advisor and add it to our prompt? So here's the prompt we had before. The only thing we're going to add here is the following. Dot advisors, retrieval augmentation advisor. So we've loaded our database. It's ready. We've added the vector advisor. And we've told it that we want to use PG vector store. So let's reorder our last item. I want cat food, dog food, and a Lamborghini. Good.
Thank you for your order. Just to confirm, you've requested cat food, dog food, and a Lamborghini. I can definitely help with the cat food and dog food, but it looks like a Lamborghini isn't something we offer on our menu.
So
Could
now,
you please confirm if you'd like to proceed with just the cat food and dog food.
so what we have now is a RAG that will, by adding RAG and putting the menu into our prompt, utilizing it, we now have the ability to challenge the user if they order something that's not on our menu. Pretty cool, right? So now what we want to do is take the next step. I want to do two more things. I need to send the order over for fulfillment, right? But I also want to be able to maybe get a price. How much is cat food, dog food, ferret food, whatever, right? So let's add that feature. So we're going to start phase 3. Oh, let me do get stash. Just get rid of those changes I just did. Check out phase 3. There we go. Now, we want to do a couple things here. So let's do this. I have another related problem. I have a lot of problems in my life. Do you want to hear about it? Okay. All right, it started when I was a kid. Okay, no, there we go. So what we want to do first is we realize that we go back to our main app and we've added a little bit extra here. So what we've added is we get our chat service, we get our response, right? That hasn't changed. Uh-oh. Chat service is doing a little more here. It's doing a get order JSON. What is this? Well, I want to take and get just the items out of the order, just the items, and I want to feed that JSON to something that can actually provide a price for us. Okay, so let's see what that looks like. And we see that we've added respond with total. Okay, well let's see what the chat service does. So we go look at get order JSON, and we see from the order given, extract the items to the following order in an unformatted JSON in the smallest size possible and with the following fields: item name, size, and quantity. Now, what does this do? It now provides me just the items. Now that I have my order items, great, as a string, what do I do with these things? So I get my items and then I call respond with total. Okay, respond from total gives me another prompt. Gosh, another prompt. Get the total price from the string provided. Okay, now how will our model know how much this cost, right? It doesn't know. It doesn't know about Spring Pet Clinic's pet food prices. Well, let's modify our chat response this is a new prompt actually, and we just take the regular chat response but we apply something called tools. And tools says, okay, if you see a particular type of prompt, please, run this function. So what does that look like? Very small. There we go. So in this case, what we see is that we have a method called price order, and it says if the tool, meaning if you see something like this, get the total price from the string provided, please apply a price here from that JSON that says, okay, I want to multiply the item quantity times the price multiplier, which right now everything's $2, and I want you to make that calculation and return the sum. Now, what we will see here on the chat service is that we're now going to get back a price for that order. Okay? We then cheat a little, and we take the original response, add in the response total, so now we'll get a confirmed order for the items we ordered, plus now the price. And the price is up to date. So now we have but one other problem we need to do: fulfillment. I need to send this order to fulfillment. I need to get this work done. We need to order, need the dog food and the cat food. The dog is hungry, all right? So in this case, what we want to do is go to and create a fulfillment class. So the way we're going to do that is we're going to go do a new package, and we're going to call it fulfillment. There we go. Create a class. I bet you'll never guess what the class is going to be called. Y'all are brilliant, yes! So thank you. There we go. There we go. Fulfillment. You're like, man, that was way too excited for that, but I'm like, hey, caffeine. So there we go. We're going to go ahead and not worry about adding that to repo. So we have fulfillment. In this case, what we want to do is, how are we going to communicate with I'm using Rabbit. How am I going to communicate with it? Let's go back to our POM file. In our POM file, let's add one more thing here. Okay? We want to add a Rabbit dependency, but in this case, we want to add Spring Cloud Stream Binder Rabbit. And what this is going to do is it's going to basically auto-configure a way in which we can either A, tie our functions into either Rabbit exchanges, or if I'm using Kafka, I could hook it into Kafka topics, and it's going to do a lot of this behind the scenes for me, and all I have to use is a series of properties to tell how I want to configure it, where I want it to go, all that good stuff. So it's really, really simplifies the process of communicating with a messaging framework. So what am I going to use here? I'm going to go to fulfillment, and I'm going to go ahead and it's going to auto-configure something for me. And what we want to have is what's called a stream bridge. And we have our stream bridge. Wow, that's cool. No, that's not what I want. Come on, there we go. Stream bridge. There we go. And we're going to make sure we include that. We're going to have a constructor here. And it's going to be public fulfillment. And then we're going to say, yep, we'll have our stream bridge. Then we're going to create a method called public void have fulfill. We're going to pass it in order. All right? And then from that order, we're going to say string bridge send, but we're going to have orders on, and there we go, orders, and then we're going to do a message builder. Oh, there we go. This is live coding. Here we go, with payload order, and we'll get rid of the build. And I think it's, see, one related problem. I think I misspelled it. Order object. Oh, what did I put in for order? Okay, order, fulfill, public. Cannot resolve fulfill.
Fulfillment.
Ah, see, look at y'all. Y'all rock. See? In class name? Yep, you're right. Thank you. Gosh, I need it. I'll tell you what, who answered me? Can you meet me at the registration booth? I'm going to give you a hat. Serious, meet me after this. And we will change that to right answers only, my friend. And what we'll do is change that to fulfillment. There we go. There we go. Now we're all happy. So now we have our fulfillment. Now all we have to do is add our configuration, new Java class. And we'll do a cancel at configuration. And we'll do a at bean. And we'll say fulfillment. And call it fulfillment, string bridge. Yep. There we go. Now if we run it, there's one other thing I need to do. We do have something here that's called order board. And order board, we will do that. And basically the order board will just show that we actually received our message. And there was an old message there from a previous test. And then when we run it now, stop and rerun. And we're going to just use the default order, which is just dog food, cat food, and fish food, I think. We see that we actually do, it's kind of hard to see down here, but we'll see where it...
Thank you for your order. You've requested dog food, cat food, and fish food. Is that correct? The total price for the order is $6.
And then we get our order here. So what have we seen? We've seen where we can take Spring AI, blend it with other Spring projects, other technologies. They work not only together, but in cooperation. And then what we can also kind of finish out here. Let's do this here. And do the slide. So what we see is the following. With Spring AI, we had a couple of things that we saw. One is that it simplifies by giving us a consistent method of reaching out to many different types of models. The ones you saw, plus many others, are supported. So take fun and be able to play with that and know that I can switch them in and out. The other is I can show where I can blend the technologies together. That I can take like a batch and AI, blend them together to get the best strength out possible. And then lastly, I can also have them work in cooperation where one provides the data to the next technology so I can provide a solution for our users. And folks, if you want to play with what I have, please visit my repo. They're available. They can kick the tires, have some fun with it. You have the Can I Have Your Order, which does basically the RAG implementation. And then you have the menu batch that actually does the loading of the data into the vector store. And I think we have some time for questions if you have any questions. All right.
I have one. The tool, the one that said tool, is that dealing with the agentic part, or is it just a tool?
Just a tool. Right. In this case, it's just you're calling a function. And basically, by applying your tooling, you're saying that I offer this function to be called if I see this particular prompt.